Ladies and gentlemen, boys and girls, children of all ages, we are here today to cover two things. Those two things are going to help you as you move on through this station work that we've been doing. You can write notes or you can just watch, but if you're trying to hide and do some things under your desk, that's going to make me flip out, and that would be crazy. If you're watching in other parts of this country, state, world, universe, these are some things that we may just work on and you'll probably see at a later date. First off, factor trees. On one of the questions on the mountain math assignment, it tells you to make a factor tree. Now, a factor tree is trying to get all the way down to prime factors. All the way down to prime factors. And it goes a little something like this. Hit it! And we have the number 36. And we have the number 3. And we're going to take this and we're going to make like a tree. Which means I need two numbers that multiply together to equal 36. It does not matter which two numbers you choose. It does not matter. Zoe?
I chose 6 times 6.
6 times 6. If you chose 12 times 3, 9 times 4, 2 times 18, you're going to get the same prime factors when you're done. Okay? You're going to get the same prime factors when you're done. So now, class, is 6 prime? No. It has more than 1 and 6 as a factor. There is, once you get to only 1 and the number, that makes it prime, which is also going to help you on one of your stations. Just saying. All right, so since we've decided that 6 is a composite number, then we need to find factors that multiply together to equal 6. Tristan?
3 times 2 and then times 2.
3 times 2 and 3 times 2. Those are the ways I can get 6. I can't put 6 in 1. When I'm doing this, I don't want 1 anywhere in my factor tree. No 1! Not like no one a person. No number 1 in my factor tree. Okay. All right, we good? We good? You sure? We're good? Aiden, is 3 prime or composite? Okay, if it's composite, it has numbers that multiply together to equal 3 besides 1 and 3.
Oh, no, it is prime.
It is prime. Because a prime number has 2 factors, 1 and itself. So obviously a composite number has more than 2 factors. More than 2 factors. So when we get to a prime number here, we circle it. We're done. So I know that these 3's are prime. I know that the 3's are prime. Tatum, is 2 a prime or composite number?
Yes.
Well, yeah, it's got to be one of them. You can't just say yes.
No, it's 2. 2 is a component.
It is a prime number. Good. The only way to multiply together to get 2 is 1 times 2. There's no other way, which makes it prime because it only has 2 factors, 1 and itself. So that makes it a prime number. Since 2 is a prime number, I put it there. This is a factor tree. You want to get down so you only have prime numbers in your factor tree. And then, if you want to do it, you'll have 2 times 2 times 3 times 3. And if you do that math, you're going to get 36. Doesn't matter if you start with 12 times 3 here, or 9 times 4 here, or 2 times 18 here. No matter what, it's going to break down to these prime numbers. This problem. Riley, you got a question? Okay. Now, if you have the number 3, which happens to be prime, you're done. Which I think is on your mountain math. This is a prime number. You cannot make a factor tree for a prime number. Because a prime number has 2 factors. 1 and itself. 1 and itself. That's it. The only way to get to 3. 1 and itself makes it prime. Composite has more than 2 ways. We already talked about 6 times 6, 18 times 2, 3 times 12, 4 times 9. So we've talked about, those are all the factors of 36. So there's more than one way to get to 36. That makes it a composite number. So that's a factor tree. It'll ask you to make one if you can on mountain math. If you can't, you're just going to say the number's prime, because you can't make a factor tree for a prime number. Because I don't want the number 1 anywhere in my factor tree. Because then that tree's going to collapse, and there's going to be a lot of dead bugs. I was going to say people, but that would be demented. I don't want to say people. So I don't want to say that. That'd be crazy. Crazy. Let's look at one more quickly. Let's look at the number 24. Phoenix, is the number 24 prime or composite? Composite. Since it's composite, I need to make a factor tree for 24. Alexis, give me a way to multiply together to get to 24 without telling me the number 1. 3 times 8. Awesome, thank you. Eric, is the number 3 prime? Yes, I'm done. We already said it was prime the last time we looked at it. The only factors of 3 are 1 and 3. No other way, no other factors. So that's prime. Eric, is 8 prime?
No.
No. Awesome sauce. Erica, since 8 is not prime, it has more than 2 factors. It's composite. So I need a way to multiply together to get 8 without using the number 1. Hit me. 4 times 2. Erica, is 4 prime? It's composite. I'll tell you a little secret. The only even number that is prime is 2. That's the only even number that is prime. But not every odd number is prime. But the only even number that is prime is 2. All right. So Erica, is the number 2 prime? Yes. She knows because I just said the only even number that's prime is 2. That's funny. Chase!
Yep.
4 is composite. Erica told us. So give me a factor pair that multiplies together equal 4.
2 times
2 times 2. Erica told us 2 is prime. So the prime factorization of 24 is 2 times 2 times 2 times 3. If you multiplied that together, you would get 24. Let's look at just, Silas, I'm gonna get you here. Silas, what is 2 times 2 times 2?
8.
8.
No.
No.
6.
Oh, yeah.
Not 6. What's 2 times 2?
4. 4.
Times 2.
6.
4 times 2 is not 6.
8.
It is 8. Silas had it. Good. Brilliant, Silas.
I am.
Brilliant. All right, one more problem, a quick division problem. One thing I've noticed when we're doing division is we're having trouble with where to place the decimal point and how many numbers in front of the decimal point and how many numbers behind the decimal point. So let's look at one problem. I have $7.71 divided by 3. That's my dividend. It's inside the house, if you like to say it as a young child, which you're not young. That's my divisor. And so that's outside the house. Know the words. Know the words.
I never learned this.
Well, now you have.
Outside and inside.
Oh. So we're going to divide $7.71 by 3. It's like Celeste went to lunch. It total cost $7.71, but she's splitting it between 3 people, so y'all have to pitch in money. I don't know where you went to lunch, Celeste. Must be Taco Bell, because that's, I don't want to say cheap, but you can eat a lot of food for a little bit of money at Taco Bell. I'm just saying. I'm just saying.
That is true.
All right. When we're dividing by decimals, we move the decimal point up. It never, and the rock means never, moves down. Never moves down. Never moves down. Taylor, does 3 go into 7?
Yes.
Yes. I'm going to have a number in the ones place. I'm going to have a number in the tenths place. I'm going to have a number in the hundredths place. You need to know, because on one of the questions on the menu I gave you, you didn't put all the numbers up, and some of you got $9.90 when it should have been $9.09, because you didn't put the numbers above where they go. They didn't. I promise. Nathan, how many times does 3 go into 7?
2 times.
2 times. Because 3 times 2 is? 6. Nathan, 7 subtract 6 is? 1. After I subtract, if there's another number, I bring it down. That is going to go here in the quotient. Nathan, how many times does 3 go into 17?
5.
5. And what is 3 times 17?
15.
15. Nathan, what's the difference between 15 and 17?
2.
2. I've subtracted. I have another number in my hundredths place. I bring it down. Nathan, how many times does 3 go into 21?
7.
7 times. And 7 times 3 is 21. I do not have another number to bring down. I don't have to add a 0 to the back of my dividend because I don't have any parts left. But because Nathan wants to make sure he gets it correct, he's going to do the inverse operation of division, which is what, Taylor? Multiplication. So we are going to multiply our quotient, which is 2.57, times our divisor, which is 3, and I should get $7.71. I should. Now, Taylor, when I've told you to multiply and there's decimals in the problem, what do?
You see how many numbers are behind the decimal.
Okay? In this problem, there are 2 numbers behind the decimal, which means there have to be
2 behind the decimal and the answer.
2 behind the decimal in the quotient, or in the product. All right, so Taylor, you ready? Mm-hmm. This is going to be real tough.
Oh, man.
Yeah,
Okay?
really hard.
3 times 7 is?
21.
21. Did you notice that 21 is here?
Wow.
Oh.
It's always going to appear there. If whatever number you get doesn't appear there, then we're in trouble. 3 times 5 is what, Taylor?
15.
Plus 2?
17.
Oh, do we notice 17 is there?
Yes.
So I have a 7 in the tens, carry my 1. Taylor, 3 times 2 is?
6.
Plus 1 is?
7.
7. Oh, did we know my 7 is there? These,
No way.
if you compare, you're going to see all my numbers, when I multiply, are going to appear in my division. I know, right? Taylor told me there had to be two numbers behind the decimal point in the problem. 7 and 71 hundredths. 7 and 71 hundredths. It's correct. We checked it with our inverse operation. Matthew?
Have you tried multiplication?
Division. I could divide 7.71 divided by 3, and I'm going to get 2.57. Okay? Boom! Shakalaka! Peace out! God bless! Do something kind! Love ya!